Question 9, part A. I'm not going to tell you why, you should be able to work that one out. Part B is a straightforward constant acceleration problem. The easiest way to do this one is to use the formula that's on the front of the exam paper. This one. If you work it through, the initial speed is 0, the acceleration due to gravity is 10, and the distance fallen is 4.5 meters. Okay, you work that out and you'll find out what v is. If you take the square root of that answer, you'll find out the velocity. In this particular case, got 9.5 if I'm writing it to two significant figures. Second part, it is a simple momentum calculation. You need to recall that momentum is mass multiplied by velocity. Now you've got the speed from the previous question, so you're just taking the mass of the object and multiplying it by the answer in the previous question. If I write it to 3 sig fig, I've got 2380 kilogram meters per second. Now in part 3, this is the very simplest kind of conservation of momentum problem. Initially you had an object falling downwards and an object below it that was stationary, and after the collision you had two objects joined together moving with a common speed in this direction. So the momentum before was 2380, the momentum after 2380, except now you've got a much bigger mass. So the momentum equals the bigger mass, so 2000 plus 250 multiplied by whatever this common speed is. So again, solving this problem, 2380 divided by 2250. There, to three significant figures. Part 4 doesn't exist. Part C. Make sure you read the question carefully. It says calculate the loss of kinetic energy of the hammer and pile. So this is in going from moving at 1.06 meters per second. So that's how fast it's going, to 0. Obviously when it's not moving, it's got 0 kinetic energy, and you need to use the formula to work out kinetic energy. A half multiplied by mass times the speed squared. So in this case, it's a half times 2250 times 1.06 squared. That's the 3 sig fig. Now, when it says about an average force, a lot of people made a lot of hard work out of this. What you need to appreciate is work done, in this case, is 1260. Work done equals force multiplied by distance moved in the direction of the force. So in this case, the force is the unknown, and the distance moved is 0.25 meters. So it is as simple as dividing the work done by the distance moved, and you get that many newtons, so about 5 kilonewtons. The final part, part D, really this one, if I draw a diagram, if the pile is only a certain distance into the ground and then later on it's further into the ground, you can see there's now much more of it, much more surface area experiencing friction as it's pushed down into the ground, so more surface area in contact with the soil, therefore more friction.